Good evening everyone, good evening. Welcome you all again to JEE Enthuse. I hope you guys are doing great, having a good time. So people, you can first of all let me know in the chats if I'm audible and visible to everyone. Hello Ishpreet, hello Ishwara, hello Aisha, hello Ashwarya, hello Nandini, hello Uda. Hello Balaji, welcome back everyone, welcome back. Just let me know in the chats if I'm audible and visible to everyone. Yes. Perfect. Just give me some green signal from the chats, people, fast. Hello Meera, hi Irvin, hello Fazan. Hello Real Nawab. What's up? Perfect guys. Hello Nandini, welcome back everyone. Okay, so as you all must be knowing, we are done with the chapter chemical equilibrium, right? Okay, in the last session of chemical equilibrium, if you remember, we talked about something called as Chatellier's principle, okay? And tonight, we are going to cover the questions, right, which are basically the previous year asked questions in different competitive examinations, right, from the same chapter, chemical equilibrium, right? And at the same time, tomorrow, we are going to start one more chapter, which is what we call as ionic equilibrium, right? Ionic equilibrium we are going to start tomorrow, and in the tonight's session we are going to cover all the previous year questions which have been asked from the chapter chemical equilibrium. So before starting the session, the ones who are new to the channel, let me introduce myself first. Well people, my name is Wassim and I'm your chemistry master teacher writer on this JEE Enthuse channel, right? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, okay? I'm doing great, Aisha, I'm doing great. How are you? Hello, Meera, I'm doing great. I'm doing good, Ashwarya. Yes, Arshad, absolutely, I remember you. Oh my God, you scored 500 in NEET, so you are repeating it. It's okay, it's completely fine. Anyways, in a couple of days, I'm going to start the repeaters batch for the NEET 2022, right, in 2 to 3 days, right? So stay tuned. Yes. So people, you can let me know in the chats if you guys are super duper excited for the tonight's session as well, right? Let me know in the chat box if you people are super duper excited about the tonight's session as well, okay? Let me know first. Let me see the Josh of the session again. Yes. Perfect. All right, so let's get going then. Let's get started with the PYQs, with the first question which is on your screen. The question was asked in 26th August 2021 JEE Mains, right? And the same question was asked in 2016 as well. Right? That means the same question has been repeated twice in your JEE Mains, right? And I'm sure a lot of students among you, they'll be remembering the answer as well because we have solved a similar type of question many a times on the same channel, yeah? So just give it a try. Let me know its answer in the chats. Yes, it's a very, very simple and basic question, right? Let's have a look exactly how this sort of a question is to be solved. Understand properly, understand line by line, okay? Have a look guys, how this sort of a question is to be solved. Have a look. The equilibrium constant at 298 Kelvin for the reaction A plus B in equilibrium with C plus D, right? The reaction that's given to me is A plus B in equilibrium with C plus D, right? This is the reaction, and equilibrium constant for this reaction that is given to me as 100. This is given as per the question. Equilibrium constant for this reaction, yes, is given to me as 100. If the initial concentration of all the 4 species were 1 molar, so at time t is equal to 0, initially the concentration of all the 4 species was 1 molar, right? The initial concentration of all the species as per given in the question is given as 1 molar, right? The equilibrium concentration of D will be, so we are supposed to calculate the concentration of D at equilibrium. This is something which we are supposed to calculate, correct? Now let's exactly see how to solve these sort of questions. Understand properly, okay? See guys, initially at time t is equal to 0, the concentration of all the 4 species was 1 molar, right? Now I'm assuming out of 1 mole of A, let's assume X moles would have reacted with B, okay? So I'll be left with 1 minus X moles of A in the container at equilibrium, right? Okay, so there'll be 1 minus X moles of A in the container at equilibrium, or you can directly treat it as the concentration as well. So this is basically 1 minus X. This is the concentration of A left when equilibrium is attained in the reaction, right? Now have a look. Now use the stoichiometry. As per stoichiometry of the reaction is concerned, 1 mole reacts with 1 mole. So X moles of A are going to react with X moles of B. I started with 1 mole of B. Out of 1 mole of B, X moles reacted. So I'll be left with 1 minus X moles of B at equilibrium. Or you can call it directly as the concentration as well. No issues at all. Yes. So this 1 minus X is the concentration of B at equilibrium, right? Already I had some 1 molar concentration of C, yes, in the container. Now when this reaction will start, some new moles of C and D would have got formed. And at equilibrium, how many total moles of C will be there in the container? Let's check it out. I can say 1 mole of A gives 1 mole of C, so X moles are going to give me X moles. Already I had 1 moles, and apart from that, I'll be getting some X moles as well of C. So these are basically the moles of C present in the container at equilibrium, or you can call this concentration of C at equilibrium. Similarly, the concentration of D at equilibrium is again going to be 1 plus X, right? So I got the concentration of each reactant and product at equilibrium. Once you get the concentration of each reactant and product at equilibrium, what you need to do is, you need to write the expression for Kc. What is the expression for Kc? It's going to be concentration of C at equilibrium raised to the power 1 multiplied by concentration of D at equilibrium raised to the power 1, where 1 is the stoichiometry coefficient. Concentration of A at equilibrium raised to the power 1, concentration of B at equilibrium raised to the power 1, right? Let's see how it's to be solved further. Kc value as per the equation, it's given to me as 100 is equal to concentration of C at equilibrium is 1 plus X, concentration of D at equilibrium is 1 plus X. So 1 plus X plus 1 plus X multiplied by 1 plus X means 1 plus X ka square divided by concentration of A at equilibrium is 1 minus X, concentration of B at equilibrium is again 1 minus X, right? Okay, so what it's going to be? It's going to be 1 minus X, so it's 1 minus X ka square, right? 1 minus X ka square. Correct? So let me take the square common. I can write 1 plus X divided by 1 minus X whole square. If I take square root on both the sides, it's going to be 10 is equal to 1 plus X divided by 1 minus X. So from here, you get 10 minus 10X is equal. 10 minus 10X is equal to 1 plus X. And from this data, what are you getting? You're getting the value of X as 9 by 11, right? This is the value of X which you got. Yes, this is the value of X you got. X value will be simply coming out to be 9 by 11. What I was supposed to calculate exactly? As per the equation, I was supposed to calculate the concentration of D at equilibrium. As you can see, the concentration of D at equilibrium is 1 plus X. So concentration of D at equilibrium is 1 plus X. Since we have got the value of X, which is 9 by 11, so 1 plus 9 by 11 comes out to be 11 plus 9 means 20. 20 divided by 11, the value comes out to be 1.81. So this is basically 1.81 molar. This is the concentration of D at equilibrium, which I was supposed to calculate. So option B is the one which is going to be the correct one among all. You can let me know in the chats if every single thing is clear so that I can move on to the next one, right? Let me know fast in the chats. Absolutely Superman. Yes. Option B is the one which is correct. Yeah, perfect. Right? Okay, so let's get going. Let's get started with one more question. And this is the question on the screen. The question was asked in your 27th August 2021 JEE Mains. Okay, how this sort of a question is to be solved. Let's see first of all what the question is. Okay. So first of all, as per the question, when 5.1 grams of solid NH4HS is introduced in a 2-liter evacuated flask at 20 degrees centigrade, 27 degrees centigrade, 20% of the solid decomposed into the gaseous ammonia and hydrogen sulfide, right? The Kp for the reaction will be. There are many ways by means of which we can approach the question. First, you can calculate Kc. Once you get the Kc, then you can write the relation Kp is equal to Kc RT raised by delta Ng, right? That is one of the simplest ways by means of which you can solve this question, right? Okay, see first of all, okay. The question that is given to me, I'm giving you the reaction. The reaction is NH4HS NH4HS, right? In equilibrium with what? In equilibrium with ammonia and H2S, right? It is NH3 gas and H2S gas as well. Okay, this is the reaction that's given to me. Okay, and this NH4HS, it's given to me in solid form, right? This is the equation. This is the reaction. NH4HS in solid form in equilibrium with NH3 gas plus H2S gas. Okay. First of all, at time t is equal to 0, what am I given with? I'm given with the mass of reactant. I'm given with the mass of reactant. Let's convert it into moles first of all, right? What is the molar mass of NH4HS? Molar mass of NH4HS is 51 grams. So given mass divided by 51, value comes out to be 0.1, right? So the initial moles of NH4HS, which I represent by A, is given to me as 0.1. So this is going to be 0, this is going to be 0, right? The reaction is already balanced. Yeah? The reaction is already balanced. Okay? Let's assume the degree of, or let's not talk about, okay, let's talk about the degree of dissociation. Degree of dissociation of the reaction is alpha, for example. Okay? As you all must be knowing, alpha is basically equal to percentage dissociation. Percentage dissociation divided by 100. This is something which we have discussed in detail long back. Yes. Have a look. Well, when equilibrium is established in the reaction at that point of time, 20% of the reactant has got converted into product, right? So 20% of the reactant has got dissociated. So at equilibrium, I must say alpha value is simply 0.2. That's all. Alpha is 0.2. So at equilibrium, can I say I'll be left with A minus A alpha moles of reactant? Okay. Now, 1 mole gives 1 mole. So from A alpha moles, you're going to get A alpha moles. Similarly, you'll be getting A alpha moles of H2S at equilibrium. So basically, you are the moles of each reactant and product at equilibrium. And at the same time, you have got the value of A, you have got the value of alpha as well. What is A value? A value is 0.1. A value is 0.1, right? Okay, A value is 0.1. Or let's not use it yet. Let's wait for it. First of all, I got the moles of each reactant and product at equilibrium, right? In order to calculate Kc, do I need the moles of reactants and products at equilibrium? No, I need the concentration. Yes, so I need to divide all these moles of reactants and products with the volume of the system. Volume of the system is given to me as 2 liters, right? So if I divide this by 2 liters, if I divide this by 2 liters, if I divide this by 2 liters, I got the concentration of each reactant and product at equilibrium, right? Once we got the concentration of each reactant and product at equilibrium, I'll be writing the expression for Kc. Kc expression is going to be concentration of NH3 at equilibrium, which is A alpha by 2, right? A alpha divided by 2. Concentration of H2S at equilibrium, which is A alpha divided by 2 again, whole divided by concentration of NH4HS at equilibrium, which is A minus A alpha by 2, right? A minus A alpha by 2. Correct? If I take A common in the denominator, see, one of the two gets cancelled, one of the A gets cancelled. So we get something as A alpha square divided by what? Divided by 1 minus alpha. As simple as that. Because I've taken A common from here, A gets cancelled. So it's going to be A alpha square divided by, there will be 2 as well. Okay, there will be 2 multiplied by 1 minus alpha as well. Okay, I'm sure it's clear. Yes. So Kc you got. Now, if I put all the values in this expression, right? A value is given to me as 0.1. Alpha value, we got to know 0.2 divided by 2 multiplied by 1 minus alpha. 1 minus 0.2 means 0.8, right? So 2 multiplied by 0.8 is 1.6. Okay, so you got 0.02 divided by 1.6. This is the value of Kc which you got, right? But are we supposed to calculate the value of Kc or Kp? We are supposed to calculate the value of Kp, right? And we know the relation. Kp is equal to Kc RT raised to the power delta Ng, right? Kc value we have got it as 0.02 divided by 1.6. R value is given as per the equation 0.0821, or instead of 0.0821 you can use 1 by 12 as well, right? Which is again the same thing, okay? Multiplied by temperature. Temperature is given to me as how much? It is given to me as 27 degrees centigrade, that means 300 Kelvin, raised to the power delta Ng. Delta Ng means number of moles of gaseous products, which is 1 plus 1, 2, minus number of moles of gaseous reactant, which is 0. So 2 minus 0 comes out to be 2, right? So just solve this part, get the value of Kp, which I was supposed to calculate. Is that clear to everyone? Right? People, let me know in the chats if it is clear to everyone. A very simple and basic question. Yes? So first of all, I calculate the moles of each reactants and products at equilibrium, and later on I found out the concentration of each reactant and product. Once you got the concentration of each reactant and product, I use the expression to calculate Kc. Once you get the value of Kc, then you are going to use the Kc expression, right? Kc-Kp relation, and get the value of Kp as well. I'm sure it's clear to everyone, right? Let me know fast in the charts, people, so that I can move on to one more question. Yes? Surely, Rohit, you can do that. 4 months are enough. 4 months are absolutely enough to qualify it. Yeah? Perfect. So let's move on directly to one more question then. Yeah? See, guys, this is one more question. The question was asked in your 22nd July 2021 JEE Mains, right? Again, a very simple question, and I'm sure you all are going to kill this one. Yeah? See, look at the question carefully. I'm given with the value of Kp. Kp value is given to me for the reaction as per the question itself, right? Kp value is given to me as 47.9, right? The Kc for this reaction at the same temperature. Okay, we are supposed to calculate the value of Kc for the same reaction at the same temperature. So I'm simply going to use the relation between Kp and Kc, yeah? We know Kp is equal to Kc RT raised to the power delta Ng. So first of all, what is the value of delta Ng for the reaction? Delta Ng means number of moles of gaseous products minus number of moles of gaseous reactants. So we have some 2 moles of gaseous products, and we have got some 1 mole of gaseous reactant as well. So 2 minus 1 comes out to be 1. So delta Ng value you got to know as 1, right? Yes? Delta Ng value you got to know as 1. Once you got the delta Ng, you can write the Kc. You can calculate Kc. Can I say Kc is equal to Kp divided by RT raised to the power delta Ng, correct? Kp. Kp is given to me as the equation, which is 47.9 divided by R value. R value, we are going to take 0.083 as per the equation, or instead of 0.083, you can take 1 by 12 as well. Temperature is given to me as per the equation, right? It is 288 Kelvin. Yes, raised to the power delta Ng, that's 1. Now it's going to be your turn to do a bit of calculation and get the value of Kc, which I was supposed to calculate, right? You can let me know in the chat if it is clear to everyone, so that I can move on to one more. Yes, perfectly clear. The question was asked in this year, JEE Mains 22nd July attempt, right? A very simple and basic question it was. Correct? Perfect. So finally, you are getting the Kc value exactly equal to 2, right? 2.00 something you'll be getting, right? So you were supposed to write the answer closest to the nearest integer. So it's absolutely going to be 2. Yeah? Okay, there is one more question, people. The question has been asked in 25th July 2021 JEE Mains. This year only. This year the question was asked. Let's exactly see how this question is to be solved. Understand. Okay. For the reaction A plus B in equilibrium with 2C, right? I'm given the reaction A plus B. It's in equilibrium with 2 times C, right? This is the reaction. The value of equilibrium constant is 100. Okay, the value of equilibrium constant Kc is 100. Right, as per the equation. If the initial concentration of all the 3 species is 1 molar, so at time t is equal to 0, initially the concentration of all the 3 species is 1 molar, correct? Then the equilibrium concentration of C is, okay, I need to calculate the concentration of C at equilibrium. A very simpler one again, right? A very simpler one. Yeah? Now have a look. Since initial concentration of all the 3 species, all the reactants and products, it's given to be as 1 molar, correct? Okay. Now I'm going to treat this concentration in the similar way as we used to treat moles, right? I'll assume these are moles of A, these are moles of B, these are moles of C at time t is equal to 0, right? Let's assume at equilibrium, out of 1 mole of A, let's assume some X moles have reacted. So I'll be left with 1 minus X moles of A at equilibrium in the container. Now 1 mole reacts with 1 mole, so X moles of A are going to react with X moles of B. So I had some 1 mole of B, and out of 1 mole, I can say some X moles are reacting, so I'll be left with 1 minus X moles of B at equilibrium. Similarly, 1 mole gives 2 moles. So from X moles, you're going to get 2 X moles, right? So already I had some 1 mole of C, and out of that, apart from that, you're getting some 2 X moles of C at equilibrium as well, right? So at equilibrium, these are the moles of the reactants and products, right? Yes. But actually, this is the concentration, because I started with the concentration, okay? And I've treated the concentration in the similar way as we used to treat the moles. So basically, you got the concentration of each reactants and products at equilibrium, okay? Once you get the concentration of each reactant and product at equilibrium, what you are supposed to do is you'll be writing the expression of Kc. Expression of Kc is going to be simply concentration of C at equilibrium, which is 1 plus 2x, raised to the power stoichiometric coefficient, that's 2, divided by concentration of A at equilibrium, which is 1 minus x, right? Multiplied by concentration of B at equilibrium, which is again 1 minus x, right? This value is equal to 100. So this is 1 minus x means 1 minus x square, or if I take square as common, it's going to be 1 plus 2x divided by 1 minus x square is equal to 100, or I can clearly say 1 plus 2x divided by 1 minus x is equal to 10. So from this, you're going to get 1 plus 2x value equal to 10 minus 10x, correct? So you'll be getting 12x is equal to 9, right? So x is going to be 9 divided by 12. So 3 3s are 9, 3 4s are 12. X value you got to know as 3 by 4, right? X value you got to know exactly as 3 by 4. But was I supposed to calculate the value of x? I was supposed to calculate the concentration of C at equilibrium. And concentration of C at equilibrium is equal to 1 plus 2x, correct? So this is going to be 1 plus 2 times x value is equal to 3 divided by 4. So it's going to be 1, this is going to be 2. So 1 plus 3 by 2 comes out to be what? It's going to be 5 by 2, correct? So 5 by 2 molar, that means 2.5 molar is going to be the concentration, right? Or you can write it as 2.5. 2.5, or you can write it as, how do I need to show it? You can write it as 25 into 10 raised power minus 1, right? So you got the concentration of C at equilibrium, right? Which was x into 10 raised power minus 1. So x into 10 raised power minus 1 is equal to 25 into 10 raised power minus 1. So just compare the two things. So you're getting x value over here as 25, right? I'm sure it's again clear to you. Yes? So you got exactly the value of x which I was supposed to calculate, and it's coming out to be 25, yeah? I'm sure it's clear to everyone, right people? So you're getting the value of x over here as 25, correct? So should I be moving on to one more then? This is one more question. The question was asked in your 20th July 2021 mains, right? Let's see exactly how this sort of a question is to be solved. It's a very simple and basic question again. Nothing to do in this. In an equilibrium mixture, the partial pressure of SO3 is given, O2 is given, SO2 is given. The equilibrium constant Kp. Wow. Have a look. So first of all, Kp expression is going to be equal to partial pressure of SO3 at equilibrium raised power 2 divided by partial pressure of SO2 at equilibrium raised power 2 multiplied by partial pressure of O2 at equilibrium raised power 1, right? We are supposed to calculate the value of Kp, is that? Absolutely. So partial pressure of SO3 at equilibrium is given to me as 43 kilopascals, so square of it, divided by partial pressure of SO2 is given to me as 45 kilopascals, square of it, yes. Partial pressure of O2. Partial pressure of O2 is given to me in pascals, but over here I've used all the other values in kilopascals, so I'll be using it in kilopascals, right? So it's going to be 0.53 kilopascals, raised power stoichiometric coefficient 1. Now it's going to be your turn. Do the calculation and kill the question. That's all, right? A very, very simple and basic question this was, correct? Right? What is the next chapter? Next chapter I'm going to start tomorrow. It's going to be ionic equilibrium. Okay? Perfect. So let's move on then to one more question. So finally you are getting the answer as 172 into 10 raised power minus 2 kilopascals. Raised power minus 1. Yeah? Hello Ankit, welcome to JEE Enthuse. Welcome, welcome. Okay, this is one more question. The question was asked in your 5th September JEE Mains 2020, right? You can let me know the answer of this question. I'll be waiting for your answers. Give it a try. You are given the reaction. Delta H value for the reaction is given. For each of the following cases, first and second, the direction in which the equilibrium shifts. The direction in which the equilibrium shifts. It's a very simple question based on Chatelier principle, and just kill it. Let me know its answer. So first of all, the reaction that's given to me, the reaction is endothermic, right? The reaction is endothermic. Okay? And for endothermic reactions, if temperature is decreased, what happens to the equilibrium constant? Equilibrium constant decreases at the same time, right? For endothermic reactions, on increasing the temperature, equilibrium constant increases, and on decreasing the temperature, equilibrium constant decreases. And if equilibrium constant decreases, what that means? how equilibrium constant will be decreasing? Equilibrium constant will be decreasing when the equilibrium will be shifting backwards, right? When the equilibrium will be shifting towards the reactant, right? So equilibrium will be shifting towards the reactant side, as per the first part of the question, okay? So equilibrium will be shifting towards the reactant side. So either option 2 is going to be the one or option 3 is going to be the one. Now let's check one more. If pressure is increased by adding N2 at constant temperature, right? What is going to happen? If pressure is increased by adding N2, will there be any effect? Will there be any effect? See, N2 is neither the reactant nor the product in this reaction. So if you will try to add N2, nothing is going to happen to the equilibrium, so no change, right? So option C is the one which is going to be the correct one among all. You can let me know in the chats if it is clear to everyone fast. Yes, N2 is neither the reactant nor the product, so nothing is going to happen if you will just add or subtract N2 over here. Right? Perfecto. Let's move on to one more then. Okay, this is one more question. The question was asked in 6th September, JEE Mains 2020, right? And I'm sure you all can solve this one properly. It's a very basic question. Okay? Say guys, I'm given with one of the reactions. The reaction is N2 gas plus 3 times H2 gas in equilibrium with 2 times NH3 gas. This is the reaction that's given to me. Well, Kc value for this reaction is given to me as 64. What do I need to do? I need to calculate the value of Kc for this reaction. So basically, I'm going to make this reaction out of this reaction, right? Now the point is, how do we make this reaction out of this reaction? Okay, so what I'll be doing? I'll be first of all reversing the reaction. If I reverse this particular reaction, it becomes 2 times NH3 in equilibrium with N2 plus 3 times H2. And on reversing the reaction, what happens to the equilibrium constant? Equilibrium constant is inversed. So the new equilibrium constant for this reaction becomes 1 by 64, right? Okay. Now further what I'm going to do, I'm going to multiply this reaction with 1 by 2. If I multiply this reaction with 1 by 2, so it becomes NH3, it becomes 1 by 2 N2, and over here it becomes 3 by 2 H2. So since I've multiplied this reaction by 1 by 2, that 1 by 2 goes to the power of equilibrium constant, so it becomes 1 by 64 raised power 1 by 2. So the value comes out to be 1 by 8. So 1 by 8 is the new equilibrium constant for this reaction for which I was supposed to calculate, right? Okay, so 1 by 8 is going to be the answer of this question. So option 4 is the one. You can let me know in the chats if it is clear to everyone so that I can move on. Yes, perfect. Perfect, guys. Exactly, it was a very simple and basic question. Okay, one more question which was asked in your JEE Mains 2020 6th September. Again, the similar sort of question and a very simple and basic one, right? You can let me know. You can let me know its answer. This can be the simplest. I mean, this is the simplest of all the questions which have been asked from the chemical equilibrium till date. Yes? Let me know first. Let me know fast in the chats what is going to be the answer of this one. Simple, guys. You're simply supposed to write the Kp-Kc relation. See, Kp is equal to Kc RT raised to the power delta Ng. So first of all, I'm going to calculate delta Ng value for the reaction that's given to me, which is number of moles of gaseous products, that's 1, minus number of moles of gaseous reactant, which is 3 by 2. So the value comes out to be how much? Minus 1 by 2. So you got the value of delta Ng, correct? Since you got the value of delta Ng, you can clearly say Kp is equal to Kc RT raised to the power minus 1 by 2, correct? But over here I'm given with the expression. See, I can write Kc is equal to Kp divided by RT raised to the power minus 1 by 2, or this is going to be simply Kp multiplied by RT raised to the power 1 by 2, correct? So this is the relation between your Kp and Kc. right? So Kc is equal to Kp RT raised power 1 by 2. Kc is equal to Kp RT raised power 1 by 2. So option C is the one which is correct among all. Is it clear to everyone, my dear people? Let me know fast in the chats. Yes? Perfectly done. Absolutely, option C is the one which is the correct among all. Okay? So this is one more question. The question was asked in your 2019 JEE Mains 12th April second shift, right? And I'm sure all of you can solve this one as well. Jordan surely will be doing that as well. So you can let me know in the chats first of all. What is going to be the answer of this question? In which of the following equilibria Kp will be equal to Kc, right? So first of all, if I write the relation Kp is equal to Kc RT raised power delta Ng. First of all, when can be Kp equal to Kc? Kp can be equal to Kc. Kp can be equal to Kc only if delta Ng for the reaction is 0, right? If delta Ng, that reaction whose delta Ng will be 0, for that reaction Kp will be absolutely equal to Kc, right? If you look at the second reaction, what is the delta Ng value for this one? Delta Ng means number of moles of gaseous products, which is 1 plus 1, 2, minus number of moles of gaseous reactant. So 2 minus 2 comes out to be 0, right? So delta Ng for this reaction is 0. If delta Ng for this reaction is 0, you can clearly say anything raised to power 0 is 1. So Kp will be equal to Kc. So it's absolutely going to be option 2, right? In option 2, in the second reaction, delta Ng is 0. And if the delta Ng is 0, that clearly says your Kp will be equal to Kc for this, right? Yes? I'm sure it's clear to everyone. Yes? Perfect. Okay, so let's move on then to one more question. Wait. I think the question is reverse. I think the question is like this. Wait. In which of the following equilibria Kp is not equal to Kc? Right? I think this is the question. That's why this is the answer given. See, in this reaction, delta Ng is 0. Even in this reaction, delta Ng is also 0, right? Number of moles of gaseous products, 1 plus 1, 2, minus 1 plus 1, 2, right? So delta Ng is 0 for this one as well. Even delta Ng is 0 for this one as well. So in all the three reactions, second, third, and fourth, delta Ng is 0. So in all the three reactions, Kp will be equal to Kc. In the first one, delta Ng is not equal to 0. So Kp won't be equal to Kc in the first one. Right? This should be the question. In which of the following Kp is not equal to Kc? This should be the question. Right? I'm sure it's clear now. Yeah? Perfect. Okay, moving on to one more then. Okay, the question was asked in your JEE Mains 2019, 18th April, second shift. See guys, what sort of question was asked? Again, a very simple and basic one, right? And I'm sure you all can solve this one properly. Right? There won't be any issue in solving this. Okay. The reaction that's given to me is sulfur plus oxygen gives SO2, right? Its equilibrium constant is given to me, right? Equilibrium constant for this reaction is given to me as well. The equilibrium constant for this reaction. Okay, equilibrium constant for this reaction. Again, a very simple question. How we are going to solve this? Have a look. See guys, what exactly I'm going to do. If I reverse the first reaction, the reaction becomes SO2 gas in equilibrium with sulfur solid plus O2 gas, right? On reversing the reaction, equilibrium constant gets inversed, so it becomes 1 divided by 10 raised power 52, right? I reversed this reaction, so its equilibrium constant is inversed, correct? Okay. Now this is what I'm calling as reaction number 1, okay? Let me call this as reaction number 2. If I add reaction number 1 and reaction number 2, what do I get? On adding 1 and 2, I'll be getting 2s plus 3 times O2 plus SO2, right? In equilibrium with S plus O2 plus 2 times SO3, right? So what all things get cancelled out? Check it out. I just reverse the reaction, or we could have done one more thing, right? Just a second. On reversing this reaction, after that, I can multiply this reaction by 2. If I multiply this reaction by 2, it becomes 2 times SO2, gives 2 times sulfur, plus 2 times O2. Okay? And on multiplying the reaction by some number, that number goes to the power of equilibrium constant, right? So it becomes 1 divided by 10 raised power 52, whole raised power 2. So it's going to be 1 divided by 104, correct? Okay? Yes, as simple as that. So you got the equilibrium constant for this reaction. Now what you'll be doing, now you do one thing. You're going to add this reaction and this reaction. If you add the two reactions, what do you get? See, I'll clearly say you get something as 2 times SO2. This twice sulfur gets cancelled out, right? 3 times O2, 2 times O2. So there'll be 1 O2 left on this side. On the other side, what do I have? On the other side, what do I have? On the other side, I'll be having 2 times SO3, right? How did I get this reaction? I got this particular reaction by adding this one and this one. And on adding the two reactions, the equilibrium constants are multiplied. So the new equilibrium constant for this reaction is going to be 10 raised power 129 multiplied by 1 divided by 10 raised power 104. The value comes out to be simply 10 raised power 25. This is the new equilibrium constant for this reaction, and for this reaction only, I was supposed to calculate the equilibrium constant, correct? Yes, so it's going to be 10 raised power 25. Simple question this was again. Yes, I'm sure it's clear to everyone. You can let me know in the chats fast. Perfect. Okay, moving on to one more question then. This is one more question. The question was asked in your JEE Mains 2019, 12th January, right? Let's try to solve this question as well. See guys, in the chemical reaction A plus 2B in equilibrium with 2C plus 2D, okay? I'm given with a reaction in which A plus 2 times B in equilibrium with 2 times C plus D, right? The initial concentration of B was 1.5 times the initial concentration of A. So let's say the initial concentration of A is small a, right? And it's mentioned in the question, the initial concentration of B is 1.5 times A. So it's going to be 1.5 A. So initially, the concentration of this A is small a, and concentration of this B is going to be 1.5 A, right? But at equilibrium, concentration of A and B were found out to be equal. The equilibrium constant Kc for the reaction will be. So we are supposed to calculate equilibrium constant for the reaction, okay? Right? Let's have a look. Let's see exactly how this question is solved. See, at time t is equal to 0, I'm given with the moles. I'm given with the initial concentration of reactants. So this is going to be 0, this is going to be 0, right? Okay, because the reaction is not started yet. Let's assume I'm going to treat these concentrations in the similar way as we treat the moles. So this is simply going to be A minus X, right? 1 mole reacts with 2 moles, so X moles are going to react with 2X moles. So this is going to be 1.5 A minus 2X. These are the moles, or you can say concentration of reactants left at equilibrium, right? So 1 mole gives 2 moles, so X moles are going to give me 2X moles. So 1 mole gives 1 mole, so from X mole you get X moles, right? So basically you got the concentration of each reactant and product at equilibrium, right? Now it's mentioned in the question. As for the equation, the equilibrium concentration of A and B were found out to be equal. So concentration of A at equilibrium is equal to the concentration of B at equilibrium, right? Now, what is the concentration of A at equilibrium? That's A minus X. What is the concentration of B at equilibrium? That is 1.5 A minus 2X, right? So you can clearly say this is going to be A minus 1.5 A is equal to minus 2X plus A, as simple as that, right? So X value, this not A, this X, right? So you can clearly say X is equal to 0.5 A. You got the value of X. Well, when you got the value of X, right, you can put the value of X over here in the equilibrium concentrations. This is A minus X. So A minus 0.5 A, which comes out to be equal to 0.5 A, right? 1.5 A minus 2X, right? So 2 multiplied by X. So 2 multiplied by 0.5 A means A. 1.5 A minus A comes out to be 0.5 A. 2 multiplied by X. X is 0.5. So 2 multiplied by 0.5. This value comes out to be A, right? And this value is X. X is already 0.5 A. So basically I got the concentrations of each reactants and products in terms of concentration. In terms of A, sorry. I got the concentration of each reactants and products in terms of A. What do I need to get? I need to get the value of Kc. Well, if you want to write the expression for Kc, it's going to be concentration of C at equilibrium raised power 2. So it's A square. Okay, concentration of D at equilibrium, that is 0.5 A raised by its stoichiometric coefficient, that's 1, divided by concentration of this A at equilibrium, which is 0.5 A raised by its stoichiometric coefficient, that's 1. Concentration of B, which is 0.5 A raised by its stoichiometric coefficient, that's 2, right? Now it's going to be your turn to do the equation. This A square multiplied by A is A cube. This is A cube in the numerator. A cube gets cancelled out. So it becomes 0.5 divided by, this is 0.5 multiplied by 0.5 ka square, right? So this gets cancelled. So it's going to be 1 divided by 0.5 ka square, right? Okay. The equation is done and dusted. We were supposed to calculate the value of Kc, and the Kc value is done and dusted. Yes. So people, finally, what are you getting as the answer? Finally, after solving this, what are you getting? You are getting the value exactly equal to 4, right? 1 divided by 0.5 ka square. That means 1 divided by 0.25, which is going to be 100 divided by 25. That is 4, right? So 4 is going to be the exact answer of the equation. I'm sure it's again clear to you. Perfect. Okay, see what kind of question. I mean, this question was asked in your 2019 JEE Mains, 9th January, second shift. I mean, this question you must solve on your own, right? Again, the similar pattern of question, right? A2 plus B2 in equilibrium with 2 times AB. Its equilibrium constant is K1. Now we have got one more reaction whose equilibrium constant is given, the relation between K1 and K2, right? People, can you do this question on your own? Right? Can you let me know its answer in the chats? Can you let me know its answer in the chats fast? Fast. Okay, let me explain it. See, first of all, what do I need to do? What I'll be doing, first of all, if I look at the second reaction, I'll just reverse the second reaction. If I reverse the second reaction, it becomes 3 times A2 plus 3 times B2, right? In equilibrium with 6 times AB. On reversing this reaction, its equilibrium constant will be inversed, right? If the equilibrium constant for this reaction was K2, now the new equilibrium constant for this reaction becomes 1 by K2, right? So 1 by K2 is the new equilibrium constant for this reaction, okay? Now, what I'll be doing further, I'll be multiplying this reaction with 1 by 3. If I multiply this reaction by 1 by 3, it becomes A2 plus B2 in equilibrium with 2 times AB. When you multiply certain reaction by some number, that number goes to the power of equilibrium constant, right? So I multiplied this reaction by 1 by 3. That 1 by 3 will go into the power of equilibrium constant, right? So 1 by K2 raised power 1 by 3. Okay, now it's done. Now it's done. Just look at this reaction, right? Both are same. So K1 value must be equal to this. So K1 value is equal to 1 divided by K2 raised power 1 by 3, right? It's done, correct? It's done. Okay, clear? Is it clear to everyone? Let me know in the chats fast. Let me know fast in the chats if it is clear so that I can move on to one more. Yes? Perfect? Absolutely. So finally, you got the answer. Let's move on to one more. Okay. For the chemical reaction which is given to me, the amount of X3Y at equilibrium is affected by. What do you think about this one? I think this is the last question of the night session. See. First of all, for the chemical reaction 3x plus y, right? 3x plus y in equilibrium with X3y, the amount of X3y at equilibrium is affected by, right? The amount of X3Y will be affected by what? It will be affected by pressure, because on the reactant side you have got total 4 moles, on the product side you have got 1 mole, right? So when the reaction will be moving in the forward direction, number of moles are decreasing, so pressure is decreasing. In the backward direction, number of moles are increasing, so pressure is increasing, right? So since the reaction is at equilibrium, if I increase or decrease the pressure, equilibrium will shift, right? So on changing the pressure, definitely on shifting the equilibrium, the amount of X3Y, the amount of product as well as reactant will change. Point number 1. Okay, so on changing the pressure, equilibrium is going to change. And at the same time, you know, equilibrium constant depends on the temperature as well. So on changing the temperature, equilibrium constant will change. And if the equilibrium constant is changing, that simply means your equilibrium concentrations of your reactants and products are changing, right? So I can say the amount of your reactants as well as products, they are going to get changed on changing the pressure as well as temperature. So temperature and pressure, this is going to be the answer. Yeah? Right? Perfect? Okay. So option 1 was supposed to be the correct one, right? This is one more question, right? Can you let me know how do we solve this one? See guys, 1 mole of N2O4 at 300 Kelvin is kept in a closed container under 1 atm. Okay. Yes. It is heated to 600 Kelvin when 20% by mass of N2O4 decomposes into NO2. So first of all, my reaction is N2O4 gas is being decomposed to NO2. So at time t is equal to 0, the pressure of N2O4 was given to me as 1 atm, so this is going to be 0, right? And at time t is equal to 0, the temperature was 300 Kelvin. Okay? So first of all, the temperature is being doubled from 300 to 600, and if the temperature is being doubled, the pressure will be also doubled, right? So it's going to be 2 atm, this is going to be 0, this is going to be 0, right? I mean at 600 Kelvin. When the temperature is doubled from 300 to 600, so I'll say the pressure will also get doubled. Okay? Now, percentage dissociation was 20. Percentage dissociation was 20. So alpha was 0.2. Alpha was 0.2 when temperature was 300. Okay? Now when the temperature is 600, alpha is not going to be 0.2, it's going to be 0.4, right? Alpha is going to be 0.4. So at equilibrium, I'll be left with, this is going to be 2 minus 2 alpha, right? Yes? Okay? Or you can clearly say, let's leave this alpha aside, let's not call this as alpha. So see, 20% of N2O4 is getting converted into NO2, right? When the temperature was 300 Kelvin. That means 40% will be getting converted into NO2 at 600 Kelvin. Yes? Right, people? Yeah? So the pressure at 600 Kelvin was 2 atm. Now it's going to be how much? It's going to be 2 minus 0.4. It's not going to be 2 minus 0.2. It's going to be 2 minus 0.4, right? Now 1 mole gives 1 mole, so from 0.4 you get 0.8. So this is going to be 0.8, right? So these are basically the pressures of reactants and products at equilibrium, right? Once you get the pressures of reactants and products at equilibrium, so you can calculate the total pressure, the resulting pressure of the system at equilibrium, which is going to be 2 minus 0.4, the value comes out to be 1.6, plus 0.8, the value is going to be 2.4. So 2.4 atm is the resulting pressure of the system which I was supposed to calculate. Isn't it clear? Right? Simple question again this was. Right, people? Yeah? So 2.4 atm is going to be the final answer of the question. Okay, this is one more question and I'm sure you all can solve it on your own. For the reaction CO plus H2O gas gives carbon dioxide plus H2 at a given temperature, the equilibrium amount of CO2 can be increased by. On adding this suitable catalyst. Catalyst has got nothing to do with it, right? Catalyst tries to alter the speeds of the reactions, right? That's all. Nothing to do with the equilibrium constant. So what is going to be the answer of this question? How the amount of CO2 can be increased? We will have a look. If I add more carbon monoxide, if I add carbon monoxide into the system, equilibrium will try to decrease it. And how equilibrium will decrease the amount of carbon monoxide? When it will make the reaction to move in the forward direction. And when the reaction moves in the forward direction, the amount of carbon dioxide gets increased. That's something which we wanted to do, right? The amount of carbon dioxide should have got increased, right? And how it's getting increased? By adding the amount of carbon monoxide. So option D is the one which is correct among all. Isn't it again simple, right? Again the simpler one. Absolutely. So people, these were all the questions, right, from the chapter Chemical Equilibrium. And in the tomorrow session, what we are going to do is, we will be starting the new chapter which is called as Ionic Equilibrium, right? Okay. So do go through all the sessions of Chemical Equilibrium again, right? Then only there won't be, then there'll be no issue in understanding the chapter Ionic Equilibrium, right? Perfect. So with this, I'm taking a leave. I'll see you guys tomorrow at the same time. Till then, you guys take care. Bye-bye. God bless you all. and love you all. But do go through the session again, and wherever you see any sort of difficulty in understanding the concepts, you can let me know in the comments, right? Okay, take care guys, bye-bye.